Okay, I'm going to go over numbers 4 through 7 on tonight's homework. So starting with number 4, it says starting 43 feet below the surface of the water. So if we have the water and 43 feet below that surface, we have Nemo. Oops. Okay, so we got Nemo, we got our fish. And it swims at an elevation of 56 degrees to touch the boat. That is, let's change that color, on the water. Okay, how far does Nemo have to swim? And we're gonna round to the nearest tenth. So if Nemo is swimming, he's gonna swim straight to this boat. And it says that he swims at an angle of elevation of 56 degrees. So Nemo's line of sight is looking straight out into the water. If he looks up at the boat, he is going to look up at an angle of 56 degrees. Okay, so we want to know how far he's going to swim. So we want to know this length right here. So in order to find that, I'm going to break this apart so that I have my triangle. I have 43, I have X, and then I had that 56 degree angle here. That 56 degree angle is also going to be here because those are alternate interior angles. So that is going to be 56 right here. In order to figure out how far Nemo has to swim, we're gonna look at the fact that with this 56 degree angle, we have an opposite side of 43, and we have the hypotenuse X of our triangle. So we're gonna be using the trig function sine. We're gonna say the sine of 56 is equal to my opposite over, oops, sorry guys, over my hypotenuse. Okay, and we're gonna go ahead and we are gonna cross multiply. So we get 43 times 1 is 43, and then we get X times the sine of 56. Okay, in order to get X by itself, we have to divide that sine of 56 away. So we're gonna go ahead and divide that out. Okay, these signs cancel because there's one on top and bottom. So we get 43 over the sine of 56 is equal to X. So you're gonna wanna pull out your Desmos calculator or whatever calculator you have, and you're gonna say 43 divided by the sine of 56. And that's going to give me 51.867. And it says in the directions to round to the nearest tenth. So that's gonna be 51.9. So Nemo has to swim 51.9 feet. All right, let's go ahead and look at number 5. All right, so with number 5, it says a little boy standing 200 feet away from a tree. So let's go ahead and label that. He's 200 feet away from that tree. Sees a hot air balloon hovering directly over that tree. The angle of elevation from the boy's eyes, so his line of sight here, up to the balloon So that angle there is going to be 40 degrees. If the distance from the ground to the boy's eyes is 4 feet, so from here to here we have 4 feet, how far above the ground is the hot air balloon? So this is kind of tricky because we're looking first. Let me get rid of this. The first thing I want to take out is this triangle. Okay, so I'm going to take that out of my picture. And I have some labels here. I have 40 degrees. I have 200 feet. And then I would need to find X. So I need to find the distance from the hot air balloon to the boy's site of the tree. Okay, so I'm trying to find that distance first, which is going to be my X. Okay, in order to find that, I'm going to use trig, so I have to label my sides. In relationship to this 40-degree angle, I have my opposite side, and I have my adjacent side. So I have tangent, I'm going to be using. I have the tangent of 40 is equal to opposite over adjacent. We're going to cross multiply, so we get x times 1 is x, and then we're taking 200 times the tangent of 40. Sorry, guys, almost ran out of room there. So what I'm going to do is, in my Desmos calculator, I'm going to take 200, maybe, there we go, times the tangent of 40. And that's going to give me 167, let's say 0.8. Okay, that's rounded to the nearest tenth. Now, that's the distance from here to about the center of the tree. So we have 167.8. Now, the only thing that we need to do from here is add in the 4 feet from the ground to the boy's eyes to his line of sight. So we're going to say plus 4 here, which gives us a total of 171.8 feet. That's how high the hot air balloon is in the sky. Okay. All right, let's go ahead and move on to number 6. So with number 6, it says a tree casts a shadow of 20 feet long. So let's go ahead and draw our tree. Okay, so we have our tree, and it casts a shadow that's 20 feet long. So that's our shadow on the ground. Okay. The angle of elevation of the sun is 29 degrees. So if we have our sun here, and it's casting that shadow, the angle of elevation, meaning from the sun, basically to the top of the tree there, to the end of our shadow, that angle of elevation is 29 degrees. From the ground up to the sun. So how tall is the tree? So we want to know this length here. So again, I like to pull out my triangle. So we have the height of the tree. We have a 20-foot shadow. And we have a 29-degree angle there at the bottom. So what I'm going to do again is I'm going to label my sides. I have opposite, and I also have my adjacent side, so we're going to be using tangent again. So we're going to say the tangent of 29 is equal to my opposite over my adjacent. And I'm going to go ahead and I'm going to cross multiply. So we get x times 1 is x, and then we have 20 times the tangent of 29. And that's going to give me 1 11 point, let's say 1. Let's go ahead and round to the nearest tenth. So that's going to be 11.1 feet. That's how tall our tree is. Okay. That's number 6. Let's go ahead and look at number 7. So for number 7, it says a woman is basically in a hot air balloon and looks down from the hot air balloon. So let's go ahead and draw how they have a little basket on them. I know that's a really bad hot air balloon, but let's just go with it. Okay, and she looks down from that hot air balloon and she sees a sheep. Oh goodness. Let's just draw a stick sheep. Okay, so she sees a sheep below and measures the angle of depression as 35 degrees. So if she's in her hot air balloon, she's looking out, and all of a sudden she looks down to see this sheep. So that's going to be a 35-degree angle of depression. If the sheep is 125 feet from where the woman is looking down from the balloon, 125 feet from where the woman is looking down from the balloon, so 125 feet, how high off the ground is the balloon? So we want to know this here. And we want to round to the nearest foot because that's what it tells us in the directions. So again, I'm going to go ahead and I'm going to pull out that triangle. And I'm going to say, okay, well, we have X. I don't know why I put 125 degrees. Just 125 here. And we have a 35-degree angle up here. But don't forget that this angle, the 35-degree angle, and this bottom right angle are always congruent because those are alternate interior angles. So we're going to label our sides. X is going to be opposite of that 35-degree angle, and 125 is going to be my hypotenuse. So we're going to say sine, because that is opposite and hypotenuse. The sine of 35 is equal to my opposite over my hypotenuse, and we're going to cross multiply. So we get X times 1 is X. Then we have 125 times the sine of 35. Okay. Let's go ahead and let's pull up Desmos. So we can take 125 times the sine of 35, and that's going to give me 71.697. Now, it does ask me to round to the nearest foot, so that's going to be rounding to the nearest whole number. So since we have a 6 here, that's going to round that 1 up to a 2. We have the hot air balloon being 72 feet. No, that was right. 72 feet above the ground. Okay, that's all the ones I'm going to go through for today.